MS Ramaiah University of Applied Sciences.
Hi students, let us discuss determination of residual chlorine. The aim of the experiment is to determine the amount of residual chlorine present in the given water sample by starch iodine titration method. Chlorination is one of the methods of disinfection which is done in order to kill the pathogenic microorganisms present in water. The dosage of chlorine should be able to take care of future contamination besides immediate killing of microorganisms. For this reason, a residual amount of 0.2 to 0.3 ppm of chlorine should be present in water before it is distributed. Residual chlorine test is performed to measure the amount of chlorine remaining in water at the time of time. Starch iodine test is conducted for testing chlorine residual in a given water sample, depending upon the oxidizing power of free and combined chlorine residuals to convert iodine ion to free iodine. In the presence of starch, iodine produces a blue color, which is taken as an evidence of residual chlorine. The amount of chlorine residual present in the given water can be measured quantitatively by titrating the iodine released with a standard solution of reducing agents such as sodium thiosulfate. The end point of titration is indicated by the disappearance of the blue color. Experimental setup: burette 50 ml with stand, pipette 25 ml, conical flask 250 ml, funnel, test tubes, wash bottle with distilled water, water sample that is to be tested, acetic acid, standard solution that is sodium thiosulfate of known normality, potassium iodine solution, and starch indicator. Experimental procedure: wash the apparatus with distilled water, rinse the burette with sodium thiosulfate solution, fill the burette with sodium thiosulfate solution. Transfer 25 ml of water sample into conical flask using a pipette. Add 2 ml acetic acid into the conical flask. Add 5 ml potassium iodine to the same and observe the color change from colorless to straw yellow. Add 2 to 3 drops of starch indicator and observe the color change from straw yellow to blue. Titrate the sample against sodium thiosulfate solution taken in the burette until the blue color disappears. Note the initial and final burette readings. Repeat the experiment until 3 concordant values are obtained. The data collection and tabulation is as shown in the table. Residual chlorine equal to VR into NR into 35.45 into 1000 divided by Vs in milligrams per liter is calculated, where VR equal to volume of sodium thiosulfate, NR equal to normality of sodium thiosulfate, and Vs equal to volume of sample. The result of residual chlorine in milligrams per liter is presented.
Hello students, today we are going to conduct an experiment to determine the amount of residual chlorine present in given water sample using starch iodide titration method. The water before it is supplied to public is to be treated properly using various treatment methods. The final treatment method that we apply to water is disinfection. Disinfection is a process of killing or deactivating pathogenic microorganisms present in water sample. Okay, so chlorination is the most widely adopted disinfection method. So chlorine will be added to water sample before it is supplied. Chlorination not only kills bacteria at the time of chlorination, it also takes care of future contamination. In order to take care of future contamination, some amount of chlorine should be left in the water sample at the time of water supply. This amount of chlorine is known as residual chlorine. The permissible limits for residual chlorine is 0.2 to 0.3 ppm. So if it exceeds the limit, it may cause bad taste or odor and even certain diseases. So before the water is sent to the distribution system, it should be seen that the amount of residual chlorine is within the permissible limits. Therefore, test needs to be conducted before it is sent. So today we are going to demonstrate the same experiment to determine the presence of residual chlorine in the water sample. The apparatus required for this experiment are burette. This is 50 ml burette. Standard solution of known normality is taken inside the burette for the experiment. Pipette. This is 25 ml pipette. This is used to transfer known quantity of sample into conical flask. Conical flask. This is 250 ml conical flask. The water sample to be tested is taken in conical flask for titration. Funnel. This is funnel which is used to transfer standard solution into burette. Test tubes. These are test tubes. Test tubes are used to measure and add required amount of chemicals into water sample. And now we have the sample to be tested here. This is the water sample to be tested. 25 ml of sample is to be taken in conical flask. Other chemicals used for this experiment are acetic acid. This is acetic acid. 2 ml of acetic acid is to be added to water sample to maintain the pH. Sodium thiosulfate. This is the standard solution, that is 0.01 normal sodium thiosulfate. This is to be taken in burette. Potassium iodide. This is 10% potassium iodide solution. 5 ml of potassium iodide is to be added to the sample. Starch indicator. This is starch indicator. 2 to 3 drops of indicator is added to the sample to give blue color. We also have distilled water here. This is distilled water which is used to wash all the apparatus before the experiment. Before starting the experiment, we need to clean all the apparatus used for this experiment. So I'm going to wash burette. Pipette. Conical flask and funnel. After cleaning the apparatus, we need to fill the burette with sodium thiosulfate. So before filling with sodium thiosulfate, we need to rinse the burette with the same solution. Now I'm going to fill sodium thiosulfate solution in the burette. Now 25 ml of water sample is to be taken in the conical flask with the help of pipette. After taking 25 ml of water sample, 2 ml of acetic acid is to be added with the help of a test tube. Now 5 ml of potassium iodide is to be added to the sample with the help of a test tube. I have taken 5 ml. I am adding it into the sample. After adding potassium iodide solution, the color has changed into straw yellow. Now I am going to add 2 to 3 drops of starch indicator. You can observe blue color after adding starch indicator. Now this is to be titrated against sodium thiosulfate until the blue color disappears. Now I am going to start the titration. You can note the initial reading, it is 0 now. We are going to start the titration. Now you can see that the blue color has disappeared. So this is the end point. We have to note the final reading. Final reading is about 0.5 milliliters. And the same experiment is to be repeated until we get concordant values. This completes the experiment.
At MSR UAS, we spark your imagination unlike any other.